Mixtures. Elements and compounds are pure substances, but most of the materials you see every day are not. Instead, they are mixtures. A mixture is made of two or more substances, elements, compounds, or both, that are together in the same place but are not chemically combined. Mixtures differ from compounds in two ways. Each substance in a mixture keeps its individual properties. Also, the parts of a mixture are not combined in a set ratio. Think of a handful of moist soil such as that in Figure 8. If you look at the soil through a magnifier, you will find particles of sand, bits of clay, maybe even pieces of decaying plants. If you squeeze the soil, you might force out a few drops of water. A sample of soil from a different place probably won't contain the same amount of sand, clay, or water. Heterogeneous mixtures. A mixture can be heterogeneous or homogeneous. In a heterogeneous mixture, you can see the different parts. The damp soil described above is one example of a heterogeneous mixture. So is a salad. Just think of how easy it is to see the pieces of lettuce, tomatoes, cucumbers, and other ingredients the cooks put together in countless ways and amounts. Homogeneous mixtures. The substances in a homogeneous mixture are so evenly mixed that you can't see the different parts. Suppose you stir a teaspoon of sugar into a glass of water. After stirring for a little while, the sugar dissolves, and you can no longer see crystals of sugar in the water. You know the sugar is there, though, because the sugar solution tastes sweet. A solution is an example of a homogeneous mixture. A solution does not have to be a liquid, however. Air is a solution of nitrogen gas, N2, and oxygen gas, O2, plus small amounts of a few other gases. A solution can even be solid. Brass is a solution of the elements copper and zinc. Separating mixtures. Compounds and mixtures differ in yet another way. A compound can be difficult to separate into its elements, but a mixture is usually easy to separate into its components because each component keeps its own properties. Figure 10 illustrates a few of the ways you can use the properties of a mixture's components to separate them. These methods include magnetic attraction, filtration, distillation, and evaporation. In the figure, iron filings, powdered sulfur, and table salt start off mixed in a pile. Iron is attracted to a magnet, while sulfur and salt are not. Salt can be dissolved in water, but sulfur will not dissolve. So pouring a mixture of salt, sulfur, and water through a paper filter removes the sulfur. Now the remaining solution can be distilled. In distillation, a liquid solution is boiled. Components of the mixture that have different boiling points will boil away at different temperatures. As most of the water boils in Figure 10, it is cooled and then collected in a flask. Once the remaining salt water is allowed to dry, or evaporate, only the salt is left.